Okay, so we have another one of these backwards graphing problems to get through. And this one may look scary because there's an oblique asymptote in it. And maybe you're thinking, I know oblique asymptotes come from synthetic division, so does that mean I have to do synthetic division backwards? And the answer is no. The only thing you need to know about this is that the oblique asymptote right there implies we're going to have more factors on top than on bottom. Okay, maybe our final function, I don't know what it's going to look like, but maybe it's this. 3 factors on top, 2 factors on bottom. That would be top heavy, right? Have more factors of x on top, and that would produce an oblique asymptote. That's all you need the oblique asymptote information for. Okay, so let's go about just using the normal method of looking through our picture here and finding pieces of the function in the picture. So I'm going to start right here at -6. You see that's an x-intercept, so that goes on top as x plus 6. And then I'm going to move that over because I think there's going to be a lot going on here. Let's see. Next thing I'm going to look for. Oh, there's a vertical asymptote right here. Okay, vertical asymptotes are on the bottom of the function. So that's x plus 3. And then I see, what else? There's another x-intercept right there. So that's an x plus 1. And I'll come back to that x-intercept in a bit. We need to talk about that one some more, the green one. Just looking for anything else I might have missed here. Oh, there we go. We got a hole in the function sitting there at -2. So that's x plus 2 and x plus 2. Okay, so maybe you're thinking now's about the time when we should go check for the y-intercept. And that is an important step. We will be taking that, but come back to this this green y-intercept right here. See that? That is a bounce. The function dives down from the left, hits the x-axis, and then bounces off of it. And that means, if you remember from polynomials, that we have a multiplicity of 2. Okay, or in other words, an exponent of 2 right there on the x plus 1. And now we've got a problem, because if you count up your factors on top, we've got 1, 2, 3, 4 factors on top and 2 factors on bottom, and that does not produce an oblique asymptote. Remember, the top needs to be exactly 1 factor more than the bottom. So where's that extra factor coming from? And I want to point out something to you that we talked about in class, but we didn't spend that much time on this. If you notice, this function is going up right here and up right here. It is symmetric about that vertical asymptote. And when you see symmetry like that, like a mirror image, both sides going up, either up and up or down and down, when it's symmetric around the asymptote, that also implies multiplicity equal to 2. Okay, so we've got another squared factor there. Normally, when you don't have a squared factor on your asymptotes, and this is usually the case, let's say you've got an asymptote like this, your function is going to go like that and then like this. See, they're not symmetric around the asymptote. But in this case, they are, so we've got an even function. Now, let's bring this all over, because I think we've described every feature of the graph, and we have done a pretty good job in checking those exponents. So let's talk about the y-intercept. Okay, the y-intercept is found by taking the function at x equals 0. And we remember that this function might have a number in front of it. I'm just going to call that b. And once we finish multiplying this through, it's going to be equal to 1. See that y-intercept right there? Okay. So let's do the calculation. B times, well, 0 plus 6, 0 plus 1 squared, 0 plus 2 all over, 0 plus 3, 0 plus 2, okay, equals 1. Simplify that a bit. B times 6 times 1 times 2 over 9 times 2. So the 2's cancel out, and we get, I'm going to simplify this fraction a little bit. You don't need to, but I'm going to call this 2b over 3 equals 1. So we rearrange that a little bit, and we get b equals 3 over 2. Right? I multiply both sides by 3, divide them by 2. So now my final equation is this, and this is what you would type in as your answer. 3 over 2, and there's a lot more to that. 3 over 2, x plus 6, x plus 1 squared, x plus 2, x plus 3 squared, and x plus 2. There we go. That is our final equation.